Here we are going to be comparing linear functions and exponential functions. Linear functions represent a quantity in which there's a constant amount added or possibly subtracted. You know, if m is negative, you go down and over instead of up and over. This is your slope. Your slope is added or subtracted. The difference between two consecutive outputs, which means you're going to subtract to find the difference, is going to be a constant number, and that tells you that you have a linear equation. So if you subtract in each one, you see there's a difference of 30, then you know every time you're adding 30, and so it must be a linear function. Whereas an exponential function represents a quantity that is multiplied by a constant amount. To figure out if you have that, you take the ratio between the numbers. Every time you divide, you get 6.42. So you know that there's this constant ratio of 6.42, so that's the factor that it's multiplied by. So you know you have an exponential function when that happens. So linear is when it's added, multiplied means it's exponential. So looking at this table, we have some data charts from years after 2000. And so we're going to look at this data chart for two separate functions. We have the function n, and we have this function m. So two outputs for one input, and we're going to compare and see if we can figure out what's linear and what's exponential. So for both of these, we can find their initial values. The initial values are the y values with 0. So if we look at 0 on the chart, it has a y value of 100 for both n and m. So both of them have an initial value of 100. And then it says, what's the difference? Difference means subtracting, right? In math, sum is addition, difference is subtraction, a product is multiplication, and ratio means you're dividing. So we're going to subtract output values for n. So we want to look at these output values and see what's happening. So I'm going to do 110 minus 100. See what that difference is. Between those two consecutive values, it's 10. So to get from 100 to 110, we had to add 10. If we look at the next one, adding 10 will get us from 110 to 120. We can add 10 again. It'll get us from 120 to 130. Plus 10 will get us to 140. Plus 10 will get us to 150. So the difference between each of them is 10. And so for n of t, that first equation, we can write either a linear or an exponential. Well, this is added, which means we have which type? It must be a linear. We have our mx plus b. So for this one, we're going to write our slope, which is 10. And instead of x, we're going to write a t because it's n of t. So we're going to do 10 times t years plus the initial value is 100. There's our b. So we're going to say n of t must be 10t plus 100. You could test by plugging in a point. If you plug in t equals 5, you'd have 10 times 5 is 50, plus 100 gets you to that 150 y value that you're supposed to have. So you could definitely plug in a random t and make sure you get out the right number so that you know you modeled it correctly. The next part says, what's the ratio? Ratio means we're going to divide between two consecutive outputs for the function m. So I'm going to take this 300 and divide it by 100. See what we must have multiplied 100 by. So we're going to do 300 divided by 100, which gives us 3. So that means to get from 100 to 300, we multiplied by 3. We can see if that pattern continues by multiplying 300 by 3, and we really do get 900. Times 3 in our calculator is 2,700. Times 3 is 8,100. And then times 3, we also get that last value. So our ratio is 3. Each time we've multiplied by 3. So if we write our own function out of that, we have to pick between linear and exponential. Since it's multiplied, we're going to write an exponential. Exponential is of the form y equals c times a to the x. So c is the initial value of 100 times a. What is our factor here? It's a growth factor of 3. And instead of to the x, we're going to write it to the t. If you're not sure if you did it right, again, plug in a random point. You could plug in 4 to this function 100 times 3 raised to the 4th, and you should get out that 8100 that you were supposed to, so you know you modeled it correctly. So addition means write a linear equation, y equals mx plus b. If you have multiplication, you're going to write an exponential function, y equals c times a to the x.